In the figure shown, segment US and segment UT are line segments, each of length 2, and the measure of angle TUS is 60 degrees. Arcs TR and SR are each 1/6 of a circle with radius 2. What is the area of the region shown? We're going to start out with just breaking this down the middle, like this. And so we know that this angle right here is 60 degrees. We know that these sides are 2. Since these are both the same side length, these two angle measures have to be the same. And if these two angle measures are the same, angles of a triangle have to add up to 180. Then these two angle measures also have to be 60 degrees. So since this is an equilateral triangle, then we know that segment ST is 2. Therefore, then, the area of this triangle, we split it down the middle like this, that's 1. By Pythagorean theorem, this segment right here, U down to, we'll call this point P, that length is going to be root 3 squared plus 1 squared equals 2 squared. That length is going to be root 3. And therefore, the area of STU is simply 2 times root 3 over 2. It's root 3. So from here, now we're going to focus on this lower half. So we know that this arc is 1/6 of a full circle. So we just draw out maybe what that full circle would look like. Doesn't have to be exact. Maybe look something like that. And we'll call this center point A. So we know that this circle has a radius 2. So the distance from A to S is going to be 2. The distance from A to R is going to be 2. And since this is 1/6 of the circle, then this angle measure has to be 1/6 of 360 degrees. So this angle measure has to be 60 degrees. And what I want to do is make a triangle here. And as we saw in this case up here, we see that this triangle is, here's a 60-degree angle, but then these two sides are the same measure. So just like the triangle up here, these two angles must also be 60 degrees. And therefore, this length, SR, has to be 2 because it's an equilateral triangle. And so from that process there, the same is going to be true of this triangle, this circle, if we draw like that, and call this B. It's also going to be the case that we can draw two triangles like that, and it's going to be 2, 2, and 2. Therefore, the area of, I want to focus on just this region, the area of STR well, it's the exact same as this above region. STR is simply that triangle is an equilateral triangle with all side lengths 2. So that measure is going to be root 3. So for the area of this region, so far we have root 3 plus root 3. But what happened, that's not the area of this region because we overcounted. We don't want to count this region right here, this segment. We don't want to count that. So what we need to do is subtract the area of this triangle from the area of the sector. So we're going to subtract the area of the whole sector area of sector SRA is going to be equal to, it's just the area of the circle, which is pi r squared, so pi times 2 squared, and we need to divide it by 6 because it's 1/6 of the circle. So here we have 4 pi over 6, which is 2 pi over 3. So that sector has an area of 2 pi over 3. So we want to subtract 2 pi over 3, and again, we're just finding the area of that shaded region. It's 2 pi over 3 minus the area of this equilateral triangle, so minus root 3. And we want to subtract that twice. We want to subtract both of these regions, so we're subtracting that twice. So again, this area that we're subtracting is areas of the shaded region up there. And so what this is going to come out in equal is we add these together, so we have 2 root 3, and this is going to be minus 4 pi over 3 and plus 2 root 3. So here we have 4 root 3 minus 4 pi over 3, and that is the area of the region that we're concerned about. So the answer then is choice B.